Consider the following statements: Bernoulli distribution, Poisson distribution, Cauchy distribution, logistic distribution with located parameter theta. Which of the following distributions possesses monotone likelihood ratio property? So monotone likelihood ratio property means that so MLR, suppose if it is having in a statistic T of x, so this means for theta 2 greater than theta 1, so likelihood ratio f of x theta 2 divided by f of x theta 1 is non-decreasing function. It's a non-decreasing function of this T of x. Often like T is equals to x for one parameter formulas. So for Bernoulli, if we take, so for theta 2 is greater than theta 1, we are having theta 2 by theta 1 whole to the power of x into 1 minus theta 2 by 1 minus theta 1 whole to the power 1 minus x. So we can clearly see this is increasing in x. So MLR holds for this. Now if we consider for Poisson, so for Poisson is an exponential family. In fact, the natural statistic, so Poisson is exponential family with natural statistic as T of x is equals to x. So likelihood ratio, the larger, so as theta increases, this the larger theta, so for larger theta increases in x, so therefore MLR holds. Now for Cauchy, so Cauchy density is not a MLR form in x because the likelihood ratio for a shifted Cauchy is not monotone. So likelihood ratio for, we can say, shifted Cauchy is not monotone in x. So even for even the Cauchy density itself, even the Cauchy density is not MLR form in x. So therefore Cauchy is not an option. And if we consider the logistic family, so logistic family is also increasing in x as so f of x theta 2 by f of x theta 1 is increasing in x for theta 2 is greater than theta 1. So therefore three distributions, so first one, second one and fourth one, Cauchy is not the answer. So only three are having this monotone likelihood ratio property.